SV Math Teach, back one more time, this time solving systems algebraically. When solving algebraically, we up to this point have solved using substitution or elimination. And you may have a personal preference one way or the other. For me, I don't really have a preference. I look at the question and try to identify what's the best problem and solution process. Here's what I observe. I see the y equals in this one. Right off the bat, that tells me that the 2x minus 3 can go into or substitute into y. So we're going to use substitution in this one. On the right-hand side, I see that the x's, the y's, the equal signs, and the numbers are all lined up for me. That's a slam dunk for elimination. So these are the strategies that I'm going to use. Left and right substitution and elimination. And because this is review, I'm going to do this kind of quickly. If I take my 2x minus 3 and put it in the y spot, I have this. And I'm going to distribute. Remember the negative 3 or the minus 3 if you prefer. And I'm going to have 6 minus 6. Well, that's 0x. That kind of goes away. And I'm left with 9 equals 9. So this one might actually be a really nice example of something you might have forgotten. When you find that the left and the right-hand side are exactly the same, we're going to go ahead and say that there are infinitely many solutions. I expected to get a solution that I needed to solve for. The x's essentially canceled out or wiped themselves out. So infinitely many solutions is the answer. Let's check out this other one and see if we get a similar interesting result or if we get an actual result. A result like an ordered pair. IMS is a result, but let's see. Okay, so when I look at this, I see the 3 and the 2, I see the 4. So look at this. I see that y down there, and that y has a coefficient of 1. And I got to be honest, I think I can turn that 1 into a 4 or a negative 4 really, really easily by simply multiplying the second equation by negative 4. Now it's worth mentioning that you can do these problems lots of different ways, and your preferred technique might not be mine, but this is how I'm going to do it. So I'm going to rewrite the first equation. I'm going to rewrite the second equation, but I'm going to distribute this negative 4 through all 3 pieces. So I get negative 8x minus 4y and negative 40. And what I love about this, I'm going to highlight it. I love that these are opposite, which means they're going to eliminate very, very quickly using addition. I like addition because I don't have to deal with all the minus negatives and everything else that can sometimes cause issues. So when I add the top column with the bottom column, or 3x minus 8x, and I add them together, I get negative 5x. The y's cancel out. 12 and negative 40 make negative 28. I could see that this is going to be a little bit sloppy. So I'm going to go with the decimal on this one. That's going to be 5.6. All right, so since we're in deep now, let's go ahead and solve this the rest of the way. I'm going to switch colors. I'm going to take my 5.6 and I'm going to replace it in either of the first two equations in the x spot. And quite frankly, the second equation looks a little bit simpler than the first with that just plain old y there. I kind of like the look of that. So I'm going to say 2x's, which we've established as 5.6, and y is 10. So this is 10 plus 1.2 is 11.2 plus y is 10. Subtract 11.2 from both sides. And y is negative 1.2. All right, so we have our two answers. We have our two pieces of our answers. So the solution is x comes first and y comes second, and we're done. And though I'm not going to show this in this video, if I were to check this answer, I would take my 5.6 and put it here. Take my negative 1.2 and put it here, and then that better equal 12. And if it does, yay, I'm halfway there. Now I can go ahead and put my 5.6 here, my negative 1.2 there, and once again, it better equal 10. Calculators are really helpful for this, graphing calculators especially, and if that works, that means it checks and you have the correct answer.